Hi, today I'm going to be talking about resistors and placing them in series and in parallel. So if we look at down here, I have the breadboard and a bunch of resistors, and off to the left here I have the piece of paper which shows the resistors and their values. So these three here, or these three here, and then this one over here is in parallel. So these three are in series in parallel with this guy, and then these two are in series here. I have this moved out of the way for just for the time being. And then these two here are these guys, and these two here are over here. So looking at the diagram here on the paper, it looks like it might be kind of complicated or messy, but in reality it's pretty simple to follow. So with the DMM here, digital multimeter, I'm going to put it over here on ohms to make it an ohm meter. And I'm going to measure between this point here and this point right here. So I'll be measuring this equivalent resistance, and then I'll take a measurement measuring this equivalent resistance, and then I'll take another measurement measuring between this guy and this guy, so it's the whole thing. If you notice, all the resistors on the left-hand side are values of kiloohms, 1 kiloohm or greater up to 22 kiloohms, and then the resistors on the right are just in ohms, so 510 ohms. So you should get an idea knowing that these two will eventually be put in parallel with these two, and so as a hint, these will be the dominant resistors. So we'll get to that. Let me connect the first lead up here on the top, and again I'm on measurement of ohms, and I'm going to connect right here. So what I'm doing, I have these ones in connected to the DMM. So I have a 7.5 plus a 1.5 plus a 1. So these are in series, so they sum. So that's 10 kiloohms. And then that 10 kiloohms is in parallel with this single 10 kiloohm. And when resistors are in parallel, the value goes down. And because this is a 10K and this is a 10K, the equivalent resistance is half that, so 5K. And that's what we see on the DMM here. I'll move this down here and move this here. So here we have two 15K ohm resistors, kiloohm resistors here, and then two 22 kiloohm resistors in parallel. And the equivalent resistance is 41K. So again, that's measuring from here down to here. And I will now measure, put this resistor back in the breadboard. So now I'm going to measure this whole circuit here, and it's 46 ohms or 46 kiloohms. So again, we measured this to be 5K, and 5K plus 30K, 35K plus 11K is 46K. And the final step, so 46K, kind of remember that. Put this right here. So what that is doing is bringing this series and parallel combination of resistors into the circuit along with these two resistors. So this leg is in parallel with this leg. And the overall resistance is almost 1 kiloohm, and if you sum these two, that's 1,020 ohms, or about 1.02 kiloohms, and then in parallel with this big 46K. So when you have a small, the point is when you have a smaller resistor in parallel with a bigger resistor like we have in here, regardless of how this configuration is, we have some in parallel, some in series, the smaller resistor will always override, per se, the bigger resistor. So this was 46K, it's almost insignificant. It's going to bring the total resistance down a little bit. That's why it's 994 ohms. This series combination is over 1,000 ohms. It's going to bring it down a little bit. But again, the point is a bigger resistor, 46K, is pretty insignificant to these smaller resistors. So hopefully that helps explain a little bit resistors in parallel and in series, and how you can calculate and then also measure in the lab the equivalent resistance. Thanks for watching.